So, we've just been talking over how we might solve this, and I've just been drawing a diagram.
Okay.
Oh, I suppose I can share my screen. There we go. This problem is a torque problem.
Yep.
And past that...
Not too hard. Shouldn't be too bad.
Shouldn't be. Oopsies. So, angular momentum principle, torque, no friction, no air resistance. This system is going to be the arm, the counterweight, the load, and the earth. Surroundings will have nothing. And the general strategy, find the torque of everything and set it equal to 0. Cool. Okay. So, torque of everything. Wow, that's not what I wanted.
So it'll be like torque of the counterweight plus torque of the... Are we splitting the arm up into two?
I think we
Yes.
might need to.
Okay.
Plus the torque of the right arm plus the torque of the load. Is it just those 4?
I believe so, yeah.
Oh, yeah. That's what it looks like. Okay.
Are we just
And
using
they're all just
P for torque?
Yeah. I mean, I suppose I could use Q. No, that's taken. I could use these 3 dots. Upright, diagonal, ellipsis. Oh. Tau. I suppose I could use tau, but that's a lot to type. I'll think about it.
just go at the very end and do the replace. Replace all, well, but that might change some of the words.
Yeah, I would change them all to /
Yeah.
tau. Well, let's see if it works now. Oh, oopsies.
Do we get specific values?
We only have variables.
Okay,
T. I don't know how to do this. Anyway, torque of the counterweight is R cross the net force. That would be x times mass times gravity. Oh, except we have to make it fancy. Mass of the counterweight is mc. That's what we are.
Okay, wait.
Wait.
Oh,
Mhm.
We
What?
do that for every torque.
Yes.
is it negative?
This would be negative.
Okay.
Mhm. The left arm torque would be equal to
Wait. Never mind. Go ahead. Keep going.
E times the.
actually I think it would be I'm thinking it might be E over 2. Because it would, because all of the weight isn't distributed at the ends, it's evenly distributed, so we have to do the center of mass. So that would be, if the length is E, then it'd be E over 2, is where the center of mass would be. E over 2 times, look at these line heights. E over 2 times mass of the arm. The entire mass of the arm would be, oh gosh,
Wouldn't it just be E over L?
times, yeah, the mass of the arm. E over,
Wait, I don't get it, sorry. Why are we using E over 2?
because that's where the center of mass is.
That's for R. Yeah. Well, those would be two separate values. It would be E squared then. Because isn't it, because the R is E over 2, but then you multiply by E over L to get the
Alright.
amount of mass on the left side.
Yes.
Times gravity.
Mm-hmm.
Wait, where is the E over L coming from?
That's the proportion of the mass on the left side, because if length is the entire thing, E is the portion we want, E over L is the percentage, and we're multiplying by mass.
Oh, okay.
It's just M arm. And this would also be negative, which would equal negative E squared over 2L M arm G. T right arm is equal to the same thing except oh, wait, what? Sorry, both of these would be positive. The right stuff is going to be negative. Because, yeah, the right stuff is, the left stuff is all positive, the right stuff is negative.
Why?
Because the left stuff will pull downwards, making the entire thing rotate counterclockwise. You can either do the right hand rule or remember that counterclockwise rotation is and would push the torque in the positive z-axis.
And so, when you're doing the right hand rule, it's pointing outwards in the positive z-axis.
Mm-hmm.
Why does that make things on the left
That's because
positive?
the left, the forces on the left are if you basically just let these forces act on their own. They are trying to make the entire thing rotate counterclockwise
Okay.
because they're to the left of the pivot point, and so they're pushing downwards, making the right side go upwards, left side go downwards. That's the counterclockwise rotation.
Okay.
Mm-hmm. I always do it. I like to do it with rotations, but you can also do it by taking the position vector and curling your hand or fingers or whatever in the direction of the force vector. So the position vector is going to the left. So if you like imagine your hands are like, or well, put your hand up and align align your fingers with the position vector and curl in the direction of the force. The only way you can do that is if your thumb is pointing towards you or upwards. But if it was on the right side, for instance, you would have to have your hand facing the other way.
Okay.
Yeah.
Perfect.
Cool. What is this? A plus B over L? A plus B.
Torque is equal to R perpendicular times the force, right?
Yeah.
Okay, so is R perpendicular, is that the measurement that's perpendicular to the force, or is that perpendicular to the...
Perpendicular to the force.
Okay.
Perpendicular to the position vector would be parallel with the force, and that wouldn't make any... It'd be kind of difficult to think of a way to find the... Yeah. I don't know.
Because I'm just worried about, like, what do we use the Y value or the D, like these measurements that are vertical, or those are just extra?
I don't think we need to use the Y values at all.
Okay.
Like C, D, and Y. I don't think we need any of those.
Why wouldn't we need them for the load?
Because well, why would we need them?
Why would you ask me that? Because if you're doing the force, it's gonna be the mass times it's just mass times gravity times gravity times A.
Yes.
Because you have times A.
Mm-hmm. Yeah, it'd be negative. If we needed to do anything with like energy, oopsies, then we would need the heights, but if it's torque, I don't think we need the heights. Cool, so are we missing any torques? Is it just the 4? We got the arm junk.
Yeah.
In the two weights. Yeah, okay, cool. So for the counterweight, we just got x times mg for the counterweight. For the left arm, we got e squared over 2l times the mass of the arm times g. For the right arm, we got negative a plus b squared over 2l times the mass of the arm times g. And the load, we got minus a times the mass of the load times g. Did you is that everyone else got that?
I agree. Yep.
Cool. And now we do some magic where we set all of the torques equal to 0.
I have to add all of them and set them equal to 0?
Yeah.
Mm-hmm.
With the power of copy paste.
Oh. Lucky dog.
Oh yeah.
The good thing is all the gravities cancel. I'm not about to see if
Yeah.
anything else cancels. That's fine.
With the power of copy paste, I can just move everything to the other side and flip the signs.
And we're gonna remove the gravities.
Yeah. I just thought I'd move the equal sign around a little bit. Just for fun, you know? And what else can cancel? This will be a plus b squared minus e squared over 2l. Algebra. Oh, jeez.
And then just the whole thing divided by MC.
Yeah.
What I got.
I got x equals negative b plus or minus the square root of b squared over 4ac, or minus 4ac. Anyone else? Divided by 2a.
I have a question.
I have an answer.
Why is it not E? Never mind. Wait a second. Why is it not e squared minus a plus b, like quantity squared? Why is it the other way around? Never mind. I got it.
You're welcome. I'm a master of answering questions. Well, this seems pretty complicated, but I'm happy with this answer.
Yeah, I feel like they're always a little bit complicated.
We could make it look a little nicer if you wanted.
No,
Oh,
I don't
thanks.
really.
You can, but I'll just leave it.
A plus b squared minus e squared. Ooh. Arm. We just need infinite sets of parentheses. Plus 2ALML divided by MC. Nice.
Wait, you're recording, right?
Gee, I hope so. see. Yep, there we go. I think that looks a little nicer.
Oh wait, we have other questions and answers.
God dang it.
In words, construct an argument. I feel like we never actually do this one.
Yeah, I don't remember doing these.
I don't do any of
Why?
them.
No, wait, we don't do the other ones. We don't do the ones that it's like words explain what you're about to do.
Oh yeah. Oh, I did that. I did that one this time.
Yeah.
Yeah. Justify our solution. The torque is equal to 0.
Do you want to come to the water ski? Do you want to come to the water ski thing with me?
What?
Do you want to come to the water ski thing with me?
Not really.
So if it's further, it's gonna tilt to the left, and if it's closer, it's gonna tilt to the right.
Yes.
Okay.
Cool, cool. Coolio boolio. Alright. Create another problem? How about no? Where must a person sit? Cool. Gonna be honest, if I had to write all of this, I would cry.
Yeah.
I'm crying right now.
I figured. Alright. That was easy. How does everyone feel about that?
Good.
I probably should ask
Glad it's
that before I said it was easy.
This is the most I've understood this unit.
Nice. Torque.
This is a what?
So, torque is equivalent to or analogous to change in momentum, or I guess impulse. There we go. Torque is analogous to impulse. Impulse is change in momentum. Torque is change in linear or angular momentum. Angular momentum is just momentum that is off-centered from the center of mass. If you have momentum centered with the center of mass, then it's just linear momentum. Linear in this instance means straight line. Angular in this instance means angled straight line. Or curved line.
So like in a circle around the center, or around like the pivot or center of mass.
Yes.
Perfect.
When you have angular momentum, you have to have a reference point to something. A lot of times you can have, if you have angular momentum around an object's center of mass, there will be no translational angular momentum. It'll just be rotational angular momentum. And this is because translational angular momentum is translational momentum in relation to a distant point. And so a good analogy or representation would be an orbital, or like a planet orbiting a star. The planet's orbit would be the translational angular momentum because it is sort of linear momentum in relation to the star. And the planet's rotation, the spin of the planet, would be the rotational angular momentum.
Okay, and those are just given by the two. Because you like add those up to find
Total momentum.
total momentum. And those are just like, so translational is just r times the momentum, like the total momentum, and then the rotational is just that's like the moment of inertia times omega.
Mm-hmm.
Okay. That makes sense.
Mm-hmm.
It's not bad. Not bad at all.
Yes. If you guys have any questions, you know how to contact me. Just shoot me a message on Discord. And
Okay, sounds good. I might take you up on that offer when
Cool.
that next homework comes around.
cool, no problem.
Tomorrow.
Yeah. Yeah.
I think
And-
this one, it's like, it's a lot easier to understand because I remember like my physics teacher told me like, you know, on a door, like the door handle is at the very end because like it's easier to open the door if the handle was like closer to the. Sorry, this is making no sense, but like, you know, the torque is higher if displacement from the center of mass, or where the pivot is greater.
Mhm.
Oh wait, low-key, that just made everything make more sense.
Yeah, I don't know why, but that just made everything like super easy for some reason.
Mhm.
Hit home.
Cool. I'm gonna stop recording. Nice job, guys.